The last part of the study guide is 2 word problems, and again, you'll see there are a couple of edits that I had the students make. So if they did not do that now, looking at this video will be a great way for them to fix it and make sure they have all the parts written down correctly so that they are studying the correct way to solve these different problems. So here we go. On the back side, the first word problem says, the Williams hot tub has a capacity of 324 liters. They have filled it with 89 liters and 345 milliliters of water. How much more water do they need to add to fill the whole tub? They need blank more liters, milliliters to fill the whole tub. So, they have 324 liters that's already there. I can put that in. They filled it with 89 liters and 345 milliliters. I'm solving for how much they still need to fill the whole hot tub up. So, I can't compare mixed units. I have to make them all one unit. So, in this case, I'm going to change my liters to milliliters. For every 1 liter, there's 1,000 milliliters. So, to change 324 liters to milliliters, I would multiply that by 1,000. That gets me 324,000. Down here, I have it mixed in liters and milliliters. So again, I can take my liters, which is 89, multiply that by 1,000, and then I'm going to add these 345 milliliters as well, and that will get me a total of 89,345 milliliters. So the hot tub holds 324,000 milliliters, and we filled it up with 89,345 milliliters. To figure out how much more water it needs to be completely filled up, I need to subtract. So again, I'm going to have to do a lot of what we're used to calling mom, dad, grandma, grandpa, auntie, uncle regrouping. I can't do 0 tens or 0 ones minus 5 ones, 0 tens minus 4 tens, 0 tens minus 3 tens. I'm going to come all the way over to my 1,000 and start this regrouping or borrowing process. I have 4 thousands. I'm going to take one of the thousands. That becomes 3 thousands. When I trade it in for hundreds, it takes 10 hundredths to make 1,000. I'm going to take one of those hundreds and trade it in for tens. It takes 10 tens to make 100. I'm going to take these tens, take one, trade it in for 10 ones. 10 minus 5 is 5. 9 minus 4, 9 minus 3. I cannot say 3,000 minus 9,000. I'm going to come over to the 10,000s. I have 2 10,000s. I'm going to take one. I can trade one 10,000 in for 10,000. So 3,000 plus 10 more thousands, 13,000 plus 9. That will get me 4,000. I cannot do 10, excuse me. I cannot do 1 minus 8, or I cannot do 10,000 minus 80,000. I'm going to come to the 100,000s. I have 300,000s. I'm going to take one of those. That will become 2. It takes 10 10,000s to get 100,000s. 11 minus 8, 3. 2 minus nothing, 2. Every 3 numbers, I put a comma. So, 234,655 milliliters, or because I know for every 1,000 milliliters, it's 1 liters, I could look at this as 234 liters, 655 milliliters. You should already have the first 3 letters of the password, G, R, and A. The 4th letter is Y. Moving on to the last word problem. Jeff places a pineapple with a mass of 1,783 grams on a balance scale. He balances the scale by placing 2 oranges, an apple, and a lemon on the other side. So if they're balanced, they're equivalent, they're equal. Each orange weighs 370 grams. The lemon weighs 145 grams less than the oranges combined. What's the mass of the apple? So I'm solving for the mass of the apple. Again, I've drawn a tape diagram out. In class, we worked together to fill it in. So on one side of my scale, I have the pineapple. That pineapple has a weight of 1,783 grams. On the other side, to balance it out, there are 2 oranges, and each of those oranges weighs 370 grams. This is nice and easy. They give me the exact number for the pineapple, the exact number for both of the oranges. Where it becomes tricky is determining the weight of the lemon, and then after that, our final answer that we're looking for is the weight, the mass of that apple. So for the lemon, it says the lemon weighs 145 grams less than the oranges combined. So this part of the tape diagram, the lemons, they're the exact same as the oranges because I have the lemon and then 145 grams. That would give me the equivalent of both of these oranges. So what I'm gonna have to do to try to figure out the weight of the lemon, first I have to figure out, well, what do both of the oranges weigh together? So 370 and 370. Both of the oranges weigh 740 grams. But the lemon is 145 grams less. Or you could look at it as what in 145 would get me 740. I know I'm going to have to subtract. All right, the lemon weighs 595 grams. So, my 2 oranges, each weighing 370 grams. The lemon, which we just figured out, weighs 595 grams. And the apple, which is what I'm trying to solve for, if I add all of those together, they would be equivalent to the pineapple. They would be 1,783 grams. Lucky for me, everything is in grams, so I don't have to do any conversion, but I do have to add these up and try to solve for that missing weight, the pineapple. So we're gonna do that real quick. I have 2 oranges, which we've already added, and we know that that gives us 740 grams, plus the weight of the lemon, double check my math there, sorry. Okay, so the 2 oranges and the lemon, all together they weigh 1,335 grams. So 1,335 grams and whatever the weight of the apple is would get us 1,783 grams. To find this missing value, I'm going to have to subtract. So I have my pineapple, 1,783 grams, minus the weight of the fruit that I do know, and that will give me the value of the apple. So the apple ended up being 448 grams. The last part of the password is an exclamation point.